A ball of mass 0.8 kg is attached to a string. So the ball is attached to a string like this. The distance to the center of mass of this ball from the point of support. This seems the point of support. And this distance of the ball from the point of support is 95 centimeters. It will go like this. It will swing like this, right? Right? The ball is released from rest when the string is horizontal. And when the string comes vertical, the ball collides with a block of mass 2.4 kg. This is at rest on the horizontal surface, right? What's happening here? We have this 0.8 kg ball, and we have this block which is 3 times heavy, 2.4 kg. So if this is m, this is like 3m, right? This is 95 centimeter. It goes like this and hits it. Just before the collision of the ball with the block, draw a free body diagram for the ball. Just before the collision. What is the free body diagram of the ball? Just before the collision. So this was like this. Ball, it is connected like this. And the ball is moving at this at v meter per second. And it is attached to the string. So it will have a tension. And it will have a mg acting downward. Just before the collision. Right? And will the T be equal to mg? What do you think?
Yeah, they will be equal.
Why? Is it not moving in a circular path? So that means there is a centripetal acceleration. How much is the centripetal acceleration?
Oh,
If this
that
thing is
means
L, it will be AC will be V square by L. That is the centripetal acceleration toward the center of this, right?
right.
Right. So that means T must be more than mg. So T minus
Oh,
mg, that is the net upward force. And that is
yeah.
equal to mass of the ball multiplied by V square divided by L. And how much will be the V? What is the speed of this ball? When it comes down, it loses. If this is L, it is loss in potential energy is mgl, right?
Hmm.
So loss in potential energy is equal to gain in kinetic energy.
Yeah.
So mgl will be equal to half mv square.
Yeah.
So v will be under root of 2gl, right? Under root of 2 into 9.8 into L, which is like 0.95 meter, right?
Right.
L was 0.95 meter. So this will become the velocity in meter per second. If you want, you can calculate it. Right. Anyhow, it's not being asked in this part. So this is the free body diagram
Yeah.
of the ball. Make sense?
Yeah.
Show that the speed of the ball is about 4.3. That we already did on the last page. V is equal to
Yeah.
root of 2 into G into L under root of 2 into 9.8 into 0.95. इसको निकाल लो आप कितना हो जाएगा क्यों जी
Hmm.
how much it is coming
So it's coming to 4.32.
4.32 meter per second, which is approximately equal to 4.3 meter per second.
Yeah.
Tension in the string, that also we solved. T minus mg is equal to mv square by r L.
Hmm.
Make sense? So T is equal to mg plus mv square by L, which is like m into g plus v square by L, right? Now v square by L is simply 2g, right? Can you see that? V square is 2gl. V square by L is equal to 2g, right? I can put that Tg here. So it is m into g plus 2g. It's equal to 3mg. Which is like 3 into mass was 0.8 and g is 9.8. So that is the tension in newtons. 3 into 0.8 into 9.8. This is
Okay.
nearly 30 into 0.8, nearly 24 Newton, little less than that.
Okay.
And you can calculate it, right? That will be the answer. 2.4 into 9.8 is like 9 minus 0.2. So 24 minus 0.48.
23.5.
So 3.5, yeah. Cool?
Yeah.
That's all. After the collision, the ball rebounds. So when the collision happens, this is the ball. It was going at V and it collides with this block, right? This
Yeah.
is M, this mass is 3m. 0.8, 2.4. Rebounds and the ball rebounds and the block moves with the speed of 2.16 meter per second.
Hmm.
Show that the collision is elastic. Batao. What will happen in elastic collision? They are colliding, right?
Yeah, momentum is conserved and kinetic energy is conserved.
Right. So let's say after collision, the ball is moving at let us say some v1 meter per second, and the block is moving at that already has given. It is 2.16 meter per second, right? Right. So can you find v1 from conservation of momentum?
Yeah.
बोलो क्या आ जाएगा 3m into v is equal to m into v1 plus sorry m into v. It was a ball which was moving, right? You see why I have used 3m because instead of 2.8 and 2.4 is same thing, right? It will cut, right?
Yeah.
M into v is equal to m into v1 plus 3m into 2.16, right? M to cuts. And value v already knew from the last page. The value of v was 4.32 meter per second, right? So 4.32 is equal to v1 plus 3 into 2.16, which is like 6.48. That means v1 is equal to 4.32 minus 6.48. 6.48, 4.32, 2.16 minus 2.16 meter per second. So ball is rebounding at this speed, right? Rebound is going back, right? It is actually going back at
Right.
2.16 meter per second, right? How do we show the collision is elastic?
By showing initial and final kinetic energy is equal.
Very good. How? On the left hand side, we have half into m into v square. And the
Yeah.
right hand side, we have half into ball into v1 square plus half into block into v2 square. v2 was 2.16 and v1 is also 2.16. Both are coming same, right?
Yeah.
So they are moving in opposite direction with the same velocity, right? Equal magnitude, right? So anyhow, तो कितना हो गया ये? Can we verify?
Uh,
Shall I check that half into m into v was how much? 4.32 square is equal to half into m into 2.16 square plus half into 3m into 2.16 स्क्वायर। समझ में आ रहा है?
हाँ।
हाफ एम हाफ एम हाफ एम तो कट गए, तो यहां पर बचा
यस।
4.32 स्क्वायर, और वहां पर क्या बचा? 2.16 स्क्वायर प्लस 3 into 2.16 square, which is like 4 into 2.16 square, which is like 2 into 2.16 का होल स्क्वायर, which is like 4.32 होल स्क्वायर, which is equal to LHS, राइट? तो वेरीफाइड हो गया ये। यही करने के लिए आप कह रहे थे, यू आर सेइंग इट राइट, वही चीज की हमने। इज इट गुड?
या।
कैलकुलेट द मैक्सिमम हाइट राइजन बाय द सेंटर ऑफ द बॉल। बॉल जो है कितनी ऊपर जाएगी? इट इज गोइंग एट दिस एल्बा 0.95 मीटर। नाउ इट इज गोइंग लाइक दिस, इट वाज मूविंग एट 2.32 meter per second, means half its speed has become half, right? Initially it was 4.32, it is now half, right?
या।
तो कितनी ऊपर तक जाएगी? How will we know?
Oh, so it's saying after it rebounds, how high it will go?
Right.
Okay.
तो देखो, how much is the kinetic energy? It is half into m into 2.32 square,
Yeah.
right? But so there is a pattern in the number. This 2.32, 2.16, sorry. I made a mistake, right? It was 2.16, not 2.32.
Yeah. 4.32. Yeah.
Yeah, 2.16 square. But 2.616, as we already said, is 4.32 by 2, right?
Yeah.
So it is like half into 1 by 4. This 1 by 2 square is 1 by 4 into m into 4.32 square, right?
Hmm.
But half into m into 4.32 square, was it not the initial kinetic energy?
Oh,
Which was
yeah.
nothing but mgl, right? So half
Yeah.
into m into this square is nothing but mgl. तो ये कितना बन गया ये? This become 1 by 4 into mgl, right? This is the total kinetic energy height. So how much height will go? Suppose it goes h dash. So it should be equal to mg h dash. So that means h dash will be simply L by 4, which is 0.95 by 4.
Okay.
0.2, 4 to the 8, 1, 15, 4 3 is 12, 3, 4 7, 8. Nearly 0.24 meter. इतनी हाइट तक जाएगी बॉल। I hope you understood it. You could have
Yeah.
done the calculation the normal way. You have a calculator, you could have just do it, right?
Yeah. Yeah.
Yeah. M also, I took M just to make the calculation simpler. You could have just taken 0.8 and 2.4. So that's not a big deal, right?
Yeah.
Yeah. But since I see these numbers, so I thought there was no point in not taking M, 3M, you know, M, 3M and V by 2, because I could see the connections, which makes the calculation simpler. But you have a calculator,
Yeah.
so you could have done it either way. I hope it's 100% clear the question, how you did it, right?
Yeah.
Right. Okay, next part. The coefficient of dynamic friction between the block and the rough surface is 0.4. Estimate the distance traveled by the block. ये बताओ क्या दिक्कत है? इसमें तो कोई दिक्कत नहीं होनी चाहिए। ये ब्लॉक की स्पीड से जा रहा था, इसका मास 3m वो था 2.4 kg, and it was going at 2.16 मीटर पर सेकेंड, राइट?
Yeah.
तो म्यू फ्रिक्शन दिया हुआ है इसके अंदर 0.4। जी की वैल्यू आपको पता है 9.8 ले लेते हैं, तो कितनी दूर जाके रुकेगा ये? कितनी दूर जाके रुकेगा? क्यों जी? कितनी दूर रखेगा? फ्रिक्शन फोर्स इज एक्टिंग बैकवर्ड, तो वर्क डन बाय, सपोज इट गोज बाय एस, तो वर्क बाय फ्रिक्शन कितना हो जाएगा? माइनस एफ एस। फ्रिक्शन फोर्स इज म्यू इंटू एम जी, right? And this work must be equal to the initial kinetic energy. Initial kinetic energy plus this work must be zero, right? So kinetic energy plus friction work. That is the net total mechanical energy, which is zero, right? Because that's come to rest.
Right.
Right? It means mu mgs is equal to kinetic energy of this block, half into mass into वेलोसिटी का स्पीड का स्क्वायर. तो एस निकाल लेंगे हम. हाफ इंटू 2.4 इज लाइक 1.2. तो 1.2 इंटू 2.16 स्क्वायर divided by mu, which is 0.4, into g, which is 9.8. इतने मीटर. That will become our answer to this part.
Yeah, it's 0.594.
So you should write 0.6
Okay.
or maybe 0.59, but not up to third decimal place, because mostly you are taking a second place only. Speed also. So accuracy can't be third place. Ideally, it should be, yeah, 0.59 is also okay, I think.
Okay.
I think that should be all about this question, right?
Yeah.
Then we have the next one. Bolo. A solid piece of chocolate of mass 82 gram is placed in a pan over fire. Thermal energy is transferred to the chocolate at a constant rate. The graph shows the variation with time of the temperature of the chocolate. So we are heating the chocolate. Initially, the temperature of chocolate is increasing. After that, the temperature becomes constant, right? After that, the temperature becomes constant. At 6 minutes all, the chocolate has melted.
Okay.
Now what? The specific heat of chocolate दिया हुआ है हमें, right? बताओ. Show that the average rate at which thermal energy is transferred. वो निकालनी है. तो देखो. Let the thermal rate, average rate be P. P what? Then P into T. It is the total heat during this phase. That should equal to mass of chocolate into specific heat of the chocolate
Sir, how do we get the P into T?
into change in temperature. If it is giving 15 watt, which means 15 joule per second, right? So 15 joule per second would mean that in 1 second it is giving 15 joule. So it's like power, right? And then 10 seconds it will give 150 joules.
Oh,
So
right.
power into time, that is the total heat, right? Which is
Okay.
required to melt it, right?
Yeah.
Right? But how much it is required to melt, right? Q is equal to mc delta T, right? You are familiar with this?
Yeah.
This is the Q, right?
P
Specific.
into
It should be mass of the chocolate to specify the chocolate into change in temperature. How much is the change in temperature during this much time?
it is.
This is 31
Oh, yeah.
and this is
31
45.
to 45. Yeah.
So delta T is 45 minus 31.
14.
14 degrees Celsius. Specific of chocolate is given. Or we can say 14 Kelvin also. Delta T, right? Doesn't matter.
Yeah.
So how much is the time taken? T कितना है? During the specific sensible heating.
2 minutes.
2 minutes. So that is 2 into 120. 2 into 60. Which is like 120 second, right? तो हमारी क्वेश्चन क्या बन गई? P into 120 is equal to mass of the chocolate, which is 82 gram. But here the units are joule per kilogram. So I can convert that into kilogram, right? Mass is equal to 82 gram is equal to 82 into 10 to the power minus 3 kilogram, right? And
हाँ
specific heat is 1.6 into 10 to the power 3 and delta T is 14, right? तो इससे
राइट
P निकाल लें. ये 10⁻³ और ये तो कट गए, राइट? तो P
हाँ
कितना हो गया? 82 into 1.6 into 14 divided by 120. How much is this? You can calculate it.
सर 15.3
15.3. Yeah, which is nearly 15 watt. That's what he said, right?
ओके
Right? Okay. Estimate the specific latent heat of fusion. Now see the latent heat part. How much is
हाँ
the total latent heat supplied? Bolo. Power we know is already. Power is 15.3 watt.
हाँ
How much is the time taken for latent heating?
4 minutes
Right? मतलब melting में जो time लगा,
हाँ
that is 4 minutes,
या
which is like 240 seconds.
राइट
तो फिर Q कितना हो गया? 15.3 into 240. But this must be equal to M into L.
हाँ
तो L कितना आ गया? 15.3 into 240 divided by M. And M is how much? 82 gram, right?
हाँ सो
So we can say
0.5
88 into 10 to the power minus 3.
हाँ
So this will be latent heat unit क्या होंगे? Joule per kg. Joule per kg. This you can calculate. 10 to the power minus 3 become plus 3.
4.5 into 10 to the power 4
4.5 into 10 to the power 4 joule per kg. So that is the latent heat of this chocolate, right?
हाँ
Hmm. Is it more than water? What is the specific latent heat of water? It is nearly 540 calorie per gram, which means 540 into 4.2 into 10 to the power 3. ये कितना होता है? I'm just curious. 540 into 4.2 into 10 to the power 3.
540 into 4.2 2.27 into 10 to the power 6
2.27 into 10 to the power 6.
या
अच्छा. Why? अच्छा, this is 82, right? Okay. This is near 45 into 10. Yeah. So the much lesser, easy to melt, right?
हाँ
No, this is just melting. I'm sorry. Melting तो बहुत कम होता है पानी का. This is what boiling. I'm sorry. I made a mistake.
ओके
We are talking about the
बट
ice to water here, right? Solid to liquid.
सो
For
हाँ
water
फिर
is 80 calorie per gram, right? So it will be like 80 into 4.2. इतना joule per gram. So per kg it will be times per 3. So it's like 8 to the 16, 6, 1, 336 into 10 to the power 3,
336,000
which is like 3.36 into 10 to the power 5. It is still pretty more than this, right?
या
3.6. Yeah. So obviously water is much difficult to melt compared to the melting the chocolate, right? Chocolate,
हाँ
तो, yeah, easy to melt, right? It melts in the mouth.
या
हाँ. But mouth temperature इतना ज़्यादा तो नहीं होता. तो I think this is just a way of saying that chocolate melts in the mouth because the melting point is 45 degrees Celsius. The temperature inside the mouth is only 37 degrees Celsius, right?
हाँ
Chocolate won't melt as such because of the heat, but it melts because it gets dissolved because of the enzymes or the, our, the liquids in the mouth, right?
राइट
Right. Not because of the temperature alone.
हाँ
because it is not melting at 37. Anyhow, this is beside the point. ये ठीक हो गया? Any questions?
No.
Compare the internal energy of the chocolate at t is equal to 2 minutes with that at 60 is equal to 6 minutes. So increase in internal energy is equal to heat at it. Heat added during 2 to 6 minutes.
Yeah.
And how much heat is added? That is power into time. Power we already know is how much? We calculated, right? It was
15.3.
15.3. So 15.3 into 4 minutes means 4 into 60, right?
हाँ.
तो इतने जूल्स, जो भी आंसर आएगा. That is the increase in internal energy. Make sense?
Yeah.
So we can say,
367.
हाँ जी,
So
360,
then 3672.
3672. Okay. So we can say internal energy increases by 3672 joules, which must be equal to m into L, right? उसी से तो हमने निकाला था L. तो एक ही बात आएगी.
हाँ.
It transfers water wave. This is the transverse wave on the water surface, like ripples in the water, right?
Yeah.
Travels to the right. The diagram shows the shape of the surface of the water. Shape of the surface of the water. These are water ripples, right?
Yeah.
Surface पे तो ripples कहते हैं ना उनको. So these are the water ripples on the surface. At time t is equal to 0. P and Q show two corks floating on the surface, right?
So just a second.
What is meant by transverse wave? You can write that. It is a mechanical wave. Yeah, mechanical लेने जरूरत नहीं है. Light is also transverse wave. A wave in which the direction of disturbance is perpendicular
To energy transfer.
to the direction of the wave propagation.
हाँ.
Wave propagation. Disturbance. I like this, right? It's always, personally, I think that's good to make a sketch.
Okay.
The frequency of the wave is this much. Calculate the speed of the wave. Calculate the speed of the wave. Right. Frequency is given.
हाँ.
स्पीड के लिए क्या चाहिए होता है हमें?
Lambda.
हाँ, वेरी गुड. एफ लैम्डा. एफ तो दिया हुआ है तो लैम्डा निकालना पड़ेगा. लैम्डा कैसे निकालेंगे बताओ?
We can just see on the graph.
Distance between this is lambda.
हाँ. It's
Right?
around 16 meters.
Yeah, this is like lambda by 4. This is lambda by 2, right?
Yeah.
तो this is, अच्छा, ये कितना है? 5, 6, 7, 8. एंड दिस इज कितना बता रहे हो आप?
16.
यहां से देख सकते हैं ये लैम्डा बाई 2 है. ये 0 से ले लें. हाँ, 0 से आप ठीक कह रहे हो. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16, राइट?
Yeah.
या तो लैम्डा 16, राइट?
Yeah.
यहां से यहां तक भी लैम्डा ही है।
हाँ.
वन क्रस्ट एंड वन होल टर्फ,
Yeah.
तो लैम्डा 16 मीटर, राइट?
Yeah.
It is 16 meter, right? 16 meter. So these are not really ripples. Ripples do not have such long wavelength, right?
Yeah.
They are like full-fledged waves, right?
Yeah.
On the water surface. They have a long wavelength, right?
Right.
All right. So C is equal to F lambda हम निकाल लें. 0.5 into 16, which is like 8 meter per second. That becomes our answer. Plot on the diagram the position of P at time t is equal to 0.5 second. Position of P, right? This is at t is equal to 0, right?
Yeah.
The wave is moving to the right, right?
Yeah.
So wave is moving to the right means what? This point is moving this way, right?
Yeah.
Your future is toward your left. Your future is toward your left. And your left particles are above. That means P is right now going up. And Q is going down, right? Because the points on the left side of it, they are below the mean position, right? So P is going up, Q is going down, right? So P is going up, right? P is going up, right? In 1/4 time period, it will reach the time top, right? In 1/4 of the time period. How much is the time period?
Sir, I don't understand the movement of the wave.
Moment of what?
Of the wave, like of the points P and Q.
देखो, ये वेव जो इधर जा रही है, ठीक है,
हाँ.
किस स्पीड से जा रही है? 8
8
मीटर पर
meters.
सेकंड से। इसका मतलब ये क्रस्ट है, ये इस तरफ जा रहा है 8 मीटर पर सेकंड से।
Right.
ये वाला पॉइंट जा रहा है 8 मीटर पर सेकंड से तरफ, ठीक है? ये पॉइंट
Okay.
मतलब ये डिस्टर्बेंस जो है, तो ये पार्टिकल तो यहाँ पर है, पार्टिकल अपनी अपनी जगह एसिलेट कर रहे हैं, पार्टिकल इधर उधर नहीं जा रहे।
Okay.
पार्टिकल्स आर मूविंग ऑन इन वर्टिकल डायरेक्शन, ठीक है?
हाँ.
तो ये पार्टिकल अभी मीन पोजिशन पे है।
हाँ.
इसका मतलब थोड़ी देर बाद ये पार्टिकल ऊंचा होने वाला है, क्योंकि ये पॉइंट यहाँ पहुंच जाएगा। ये हाइट,
हाँ.
हाई बात समझ में?
हाँ.
तो दिस पार्टिकल इज मूविंग, क्योंकि इस पार्टिकल को क्या करना है? ऑसिलेट करना है। इतनी
Okay.
हाइट तक जाएगा, इतनी हाइट तक, फिर वापस आएगा, फिर नीचे जाएगा, फिर ऐसे आएगा। ऑल दीज पार्टिकल्स आर डूइंग दिस।
हाँ.
जैसे ये पार्टिकल टॉप पे है तो कहाँ जाएगा? नीचे जाएगा।
हाँ.
इसको कंफ्यूजन नहीं है, ये सबसे नीचे ऊपर जाएगा। ऐसा चम कर रहे हैं पार्टिकल्स, सिंपल
Okay.
हार्मोनिक मोशन, राइट? मगर जो
हाँ.
ये बीच में इनका पता नहीं चलता कि ऊपर जा रहे हैं कि नीचे जा रहे हैं।
हम्म.
इनका भी पता नहीं चलता कि ये नीचे जा रहे हैं ऊपर जा रहे हैं। तो हम कैसे देखते हैं? अगर वेव राइट में जा रही हो तो पार्टिकल के लेफ्ट में देखते हैं, उसके लेफ्ट वाले पार्टिकल कहाँ हैं। अगर उससे ऊपर हैं तो पार्टिकल ऊपर जाएगा, अगर उससे नीचे हैं तो पार्टिकल नीचे जाएगा। ये अपने लेफ्ट वाले की नकल मारेगा, क्योंकि वो वेव राइट साइड में पहुंच रही है।
Okay.
तो अगर कोई चीज लेफ्ट साइड से आ रही है तो आपके पास आने पहुंचने वाली है वो चीज, राइट?
हाँ.
और जो चीज राइट साइड में आपसे दूर जा चुकी है और दूर जाएगी,
Okay.
राइट? तो अभी तो ये मीन पोजिशन पे है एंड इट इज गोइंग टू अप, राइट? तो प्लॉट ऑन द डायग्राम द पोजिशन ऑफ पी एट टाइम 0.5। अब इसका एफ कितनी है? 0.5, तो उसका टाइम पीरियड कितना है? टाइम पीरियड कितना है? 1/f,
हाँ.
2 सेकेंड, राइट? इसका
या.
मतलब, हाँ जी,
या.
इसका मतलब 0.5 सेकेंड में मीन पोजिशन से ऊपर जाते हैं हम, फिर अगले 0.5 सेकेंड में वापस मीन पोजिशन पे आते हैं,
हाँ.
उसके बाद अगले 0.5 सेकेंड में लोअर पोजिशन पे जाते हैं, और फिर उसके अगले 0.5 सेकेंड में वापस आते हैं, राइट? तो ऐसे 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 ऑसिलेट कर रहे हैं पार्टिकल्स, एंड दीज ऑसिलेशंस आर सिंपल हार्मोनिक, राइट? तो
या.
पोजिशन ऑफ द पॉइंट पी एट टी इज इक्वल टू 0.5 विल बी एट द टॉप, राइट? तो एक्स कोऑर्डिनेट तो उसका सेम ही रहेगा जो अभी है। देयर इज नो
हाँ.
चेंज इन एक्स कोऑर्डिनेट।
हाँ.
तो एक्स कोऑर्डिनेट, एक्स कोऑर्डिनेट क्या हो जाएगा? जो अभी है, पी पॉइंट का एक्स कोऑर्डिनेट क्या है? इट इज एक्स इज इक्वल टू
8.
6 7 8 मीटर,
या.
एंड वाई कोऑर्डिनेट कितना हो जाएगा? 0.5 सेकेंड पे टॉप पर पहुंच जाएगा। टॉप का कितना वाई कोऑर्डिनेट है?
1.2.
Is it 1.2? 1, 2, 3, 4, 5, 6, 7, 8. These are 10 marks.
Yeah.
This is 1. Yeah, 1.2. You are right. So y will be 1.2 meter. So you can plot it. You can plot like this. You can say x and you can say y and you can say point P. This is 8 and this is 1.2. That's how you can plot it, right?
Yeah.
ये वाला पार्टिकल कहां पर होगा बताओ? After 0.5 seconds. Where will this be?
It will be at the same x position but -1.
Yeah,
Sorry,
this will be -1.2. ये नीचे पहुंच जाएगा, राइट?
हाँ
हाँ, क्योंकि नीचे जा रहा था ये ठीक बात है। ये वाला पार्टिकल कहां पहुंच जाएगा? 0.5 सेकंड में वेव कितना चल रही है? वेव स्पीड इज 8 मीटर पर सेकंड।
हाँ
तो 0.5 सेकंड में वेव कहां चल रही है? 4 मीटर, राइट?
हाँ।
इसका मतलब जो इससे 4 मीटर इधर वाला लेफ्ट वाला पार्टिकल है, ये जितनी हाइट पर है उतनी हाइट तक पहुंच जाएगा ये।
ओके
सिंपल सी बात है, राइट?
ओके।
जैसे ये देखो, ये कहां पहुंच जाएगा? इससे 4 मीटर दूर लेफ्ट साइड में कौन सा पार्टिकल है? ये वाला पार्टिकल है,
हाँ
राइट? और ये कहां पर है अभी? -1.2 पे। तो ये
हाँ।
-1.2 पे आ गया। किसी पार्टिकल की पोजीशन हम निकाल सकते हैं कहां आने वाला है। इससे 4 मीटर लेफ्ट साइड वाला पार्टिकल जितनी हाइट पे उतनी हाइट पे पहुंच जाएगा ये,
ओके।
राइट? गुड पॉइंट।
हाँ।
जैसे ये कहां पहुंच जाएगा ये वाला? आफ्टर 0.545 सेकेंड ये कहां पहुंच जाएगा? देखो, 0.5 सेकेंड मीन्स 4 मीटर। तो 4 मीटर ये वाला पॉइंट है, यहां पहुंच जाएगा मीन पोजिशन पे।
ओके।
ठीक है,
हाँ।
राइट? डज इट मेक सेंस? राइट।
या
1 सेकेंड बाद ये कहां पहुंच जाएगा? आफ्टर 1 सेकेंड। 1 सेकेंड मतलब 8 मीटर। या फिर ऐसे मान सकते हैं 1 सेकेंड मतलब 0.5 के दो पार्ट हो गए। तो
हाँ।
0.5 में इधर आ जाएगा, अगले 0.5 में यहाँ पहुंच जाएगा। तो ये सबसे नीचे आ जाएगा।
ओके।
लाइक दैट यू कैन सी ये कहाँ पहुंच जाएगा 0.5 1 सेकेंड बाद। 0.5 सेकेंड में ऊपर, 0.5 सेकेंड वापस वापस जगह पे आ जाएगा
ओके।
ये, लाइक दैट। तो यू हैव टू सी इट हैपनिंग, राइट?
हाँ।
हाँ, इट इज वेरी सिंपल दिस वे। शो दैट द फेज डायग्राम बिटवीन द ऑसिलेशंस ऑफ द टू कॉर्क। या, so these are the two corks P and Q, right? So this is one cork. It is going up right now, right? And the Q cork it was going down.
या
So what is the phase difference between them? 180 degree, right?
हाँ
In a simple harmonic motion, what happens? If you are going this way, suppose your phi is 0 phase. When you reach here, your phi is 90 degree. When you come back here, phi is 180 degree. So if you are going up and you are going down, the phase difference is 180 degree, right?
हाँ।
You can do like this. Delta phi is equal to 2 pi delta x by lambda. How much is the delta x, position difference between P and Q? It is 8 meter, right?
राइट।
8 and 16, right?
हाँ।
And lambda is 16 meter, right? Yeah, lambda was 16 meter, we got it earlier, right?
हम्म।
तो कितना हो गया? It simply become pi radian. Answer. You understood?
या
Monochromatic light is incident on two very narrow slits. Yeah, so they will make a Young's double slit pattern, right? This is a YDSE experiment. The light that passes through the slits is observed on a screen. M is the point, some directly opposite the midpoint of the slits. Right? X represents the displacement from M, right, in the direction. So what happens? यहाँ पर तो हमारे fringes आ जाएंगे इस तरीके से, right?
Bright fringes, dark fringes.
You will get the fringes like this, right?
Yeah.
How much is the distance between the two maximum? It is called lambda d by d, right? Distance between two maximum. And distance between the maximum minimum, it is half of this lambda d by 2d. इसको d को a भी कुछ लोग लिखते हैं, इसको मैंने d लिखा है और इसको a लिखा है, d कैपिटल d लिखा है. Capital D is that this distance and small d is this, right? Small d is very small and capital D is maybe 1 meter, but this may be in millimeter or even less. That's how the dimensions are taken in the YDSE. They have not given the values. A student argues that what will be observed on the screen will be a total of two bright spots opposite the slits. Opposite the slit, though, no. That is as per the conventional model. According to this student, there are two slits. That's how everyone, any common sense person will think.
Yeah.
That is going like this will reach here to bright spot. And again, bright spot. And the rest of the point will be all dark, right? Right? So he's assuming that the light travels in straight line. And light is like travels in a straight line. But here it's not true. The light, it's a wave. And from this slit, it will act as the source of secondary wavelets. From there, the cylindrical wavefront will spread. And then due to interference, there will be some fringes like this and not like this, right? This is not correct. Although classical theory say this would be like this, but this is not correct. This is according to the corpuscular theory, let's say. Newton's corpuscular theory. According to it, this will be like this. Explains the why the argument is like what I said.
Okay.
It will be a total rule, right? The student is arguing on the model that light travels in a straight line. However, this model, which treats light as a stream of particles, is not correct. Here, the light behaves as wave and governed by Huygens principles. Which states that each point on the slit, each slit will act, या फिर each point on the slit will act as source of secondary wavelets. And the pattern on the screen is formed due to interference. This is एक क्लासिक YDSE experiment and alternate bright and dark fringes will form, not two bright spots. Opposite the slits. Right? I have written a complete answer. You can just, maybe the green portion should be sufficient.
हाँ
एंड ये उसमें पूछा नहीं है और क्वेश्चन, तो फिर ये लिख भी सकते हैं अपना। अच्छा, फिर आगे है द ग्राफ शो द एक्चुअल वेरिएशन, राइट, दैट वी ऑलरेडी डिस्कस इन द प्रीवियस पार्ट। I note is the intensity of the light at the screen from one slit. So the one slit gives an I naught and the other slit give I naught. Then the maximum intensity here is 4 I naught, right? At the right point. And that is the theory, right? Yeah, 1, 2, 3, 4 I naught, right? I naught is the intensity of the light at the screen from the slits are separated by a distance of 0.18 and the distance to the screen. This is determining meter the wavelength of light, right? वो तो कैसे करेंगे हम? From the figure, fringe width कितनी आ रही है? डिस्टेंस बिटवीन टू मैक्सिमम कितना आ रहा है? ये 0 है।
हाँ
और फिर ये कितना है? ये वाला, ये मैक्सिमम कहाँ पर? यहाँ पर मैच कर रहा है वर्टिकल लाइन से, राइट? यहाँ पर तो मैच नहीं कर रहा, यहाँ मैच कर रहा है, राइट? तो 1, 2, 3, these are the three wavelength, three fringes, right? And this is 0. And how much is this? This is how much? This is 1, 1, 2, 3, 4, 5, 6, 7, 8, 10 parts had been divided. So this is 1, 2, 3 part. 1.7, right?
हाँ
So this is equal to 1.7 centimeter. Nearly, right? 3 fringes.
या
So what is the fringe width? 1.7 by 3 centimeter, right? And that should be equal to, or we can say 17 by 3 millimeter, right? And that's equal to lambda d by d, right? So lambda into capital D is how much? 2.2 meter. (7.17 by 3 is in millimeter. So I can multiply by 10 power minus 3 maybe to make into meter. And then lambda into this meter, and this also I should take meter. Then lambda will come in meter. How much is this? 0.18 millimeter, right? So 0.18 into 10 to the power minus 3 meter, right? अच्छा, ये तो हाँ ठीक है। तो मीटर मीटर कट जाएंगे, ऑलरेडी मीटर में हमने कर दिया है। तो लैम्डा निकाल लो इससे। आपको समझ में आ रहा है?
हाँ सर,
हाँ,
ये थोड़ा मेरे को फर्स्ट वाला पार्ट समझ नहीं आया जो अपन ने थ्री फ्रिंजेस का लिया, वो मतलब।
मतलब इसकी फ्रिंज विड्थ निकालनी थी, तो मैं यहां से भी ले सकता था, मगर यहां पर देखो लाइन इससे टॉप पे आ नहीं रही है, कहीं मैच नहीं कर रही है, इसलिए लिया है क्योंकि यह मैच कर रही है।
ओके
जस्ट फॉर दैट रीजन, राइट? नो अदर रीजन।
ओके
यू सी दैट
या
इट इज इजी टू रीड।
हाँ
इफ आई टेक दिस, आई हैव टू गेस समथिंग इन बिटवीन, राइट?
हाँ
Here also I have to guess something in between. So I chose this
ओके
because here I am pakka it is 1.8, right?
हाँ
1.7 rather, right? 1.8, 1.9, 2.0. आगे
हाँ
बात समझ में? That's why it took
हाँ
3, right?
ओके
That's why, no other reason, right? Make sense?
या
Right. तो फिर लैम्डा निकाल लें हम, इसको उधर ले जाए ऊपर, इसको नीचे ले जाएं, तो कितना हो जाएगा? 10⁻³ इंटू 17/3 इंटू 0.18 इंटू 10⁻³ upon 2.2 meter. That is the wavelength of this light. That is the wavelength of this light. तो मैंने 3 को इसलिए पहले कट नहीं किया था कि मैं इसको अब कट कर सकता हूँ इसको. दिस लाइक 0.6, राइट? 3 6 18. I can cut this 0.6 and this decimal also. So it's like 17 into 6/22. 17 into 6/22 into 10⁻⁻6, right?
The answer is 4.6 into 10 to the power minus 7.
4.6
Yeah,
into
10 to the power 7.
minus
Minus
7.
7, sorry. Yeah, minus 7.
अच्छा, 7 कैसे आए? 7 into 6 by, अच्छा, दिस इज 0.60 और 0.6 तो ठीक है. 0.622 17 into 6. मतलब बात तो आपकी ठीक लग रही है, 10⁻7 ही आना चाहिए, पर मेरा आ नहीं रहा. 70 into 6/22. दिस विल बी 4.6 into 10⁻⁻6. -7 कैसे आया आपका?
So I just plugged in the numbers from the calculation. I got 4.6 into 10 to the power minus 7.
This is 10⁻³ then 17/3. ओके, अच्छा, ठीक है ना, 3 है ये. तो 3 into 0.6 would be, अच्छा, 1.8. I think I made a mistake here. This will be 0.06. Yeah, you are right. Yeah, ठीक है ये. Right? Right? So this is like 4.6 into 10⁻⁻7 into 10⁻10 angstrom. So it's like 4,600 angstrom or 460 nanometer. Right? So it's a visible light, right? Because visible light spectrum is between 400 nanometer to 700 nanometer, right? Only then it makes sense. If it was not visible light, how will you see the fringe?
Right.
So our calculation correctness, you should give an answer in the range of visible lambda, right? Lambda for the visible light. So that is one simple check we have available, right? That's why I was saying it has to be 10⁻⁻7 because 10⁻⁻6 will be ultraviolet, right?
Right.
Then you can't see the fringes because
Yeah.
human eye is not capable of seeing it, right?
Yeah.
So normally they will not make this kind of mistake. They will give a practical question. आगे बढ़ें. A cell of negligible internal resistance and electromotive force is connected to 3 resistors PQR. Right? R is an ohmic resistor. Right?
Yeah.
यहाँ पे कहते हैं तो P and Q are shown. तो P and Q are not ohmic. तो
Yeah, or
P and
else it
Q
would
में
be
क्या होता है
straight.
कि जैसे जैसे वोल्टेज बढ़ती है करंट फिर धीरे धीरे उतना ज्यादा नहीं बढ़ता है. शुरू में वोल्टेज बढ़ाने से करंट जल्दी जल्दी बढ़ता है.
हाँ.
उसके बाद करंट वोल्टेज बढ़ाने से करंट जल्दी, मतलब रेजिस्टेंस बढ़ रही है.
Okay.
जैसे जैसे वोल्टेज बढ़ रही है तो रेजिस्टेंस, डायनेमिक रेजिस्टेंस कहते हैं, वो बढ़ रही है बिकॉज मोर फर्दर वोल्टेज इज नॉट गिविंग मच करंट, राइट?
Okay.
So that means the resistance is increasing as the voltage increases, right?
हाँ.
Okay. The current in P is 0.4 ampere. Here the current is 0.4 ampere. P is not an ohmic resistance, right? So 0.4 ampere means we can find the voltage here. How much is the voltage? Is how much? 1, 2, 3, 4, 5. This is 1.4, right?
हाँ.
So now with the potential difference here is 1.4 volt. But these two are in series, parallel, right? So this will also be 1.4 volt, right? When the resistors are in parallel, they will have the same voltage, right? Voltage difference across them, right?
हाँ. Yeah.
So this is also 1.4 volt, but this is an ohmic resistance, right?
Yeah.
Right. Okay. Now, this battery is 6 volt, right? If
Yeah.
this is 1.4 volt, this must be 6 minus 1.4 volt. 4.6 volt here. Because total this dropped here and here, right?
Huh.
4.6 volt means how much will be the current here? 4.6 volt, we can check the current. This is 4.6. And we can see the current here in Q at 4.6. This is how much?
0.45.
This is 0.45. You are right. So that means here the current is 0.45 ampere. Out of which 0.4 is going here. तो यहां पर कितना जा रहा है? 0.45 minus 0.4, right? Junction rule, right? Whatever is coming here is going here or here. 0.45 is coming, out of which, sorry, yeah, 0.4 is going here, and then 0.05 will be going here only, right?
Okay.
Right? 0.45 is coming, 0.4 is going here. So balance is only how much? 0.05. So that must be going here, right? Yeah. Show that the current is 0.45, that we already seen, right?
Yeah.
है ना? Read, you can read from the graph, right?
Yeah.
Graph of Q. But first you have to show that this is 4.6 volt, right? Only then you can show it, right? The way we did, right? तो आप कहोगे ऐसे कि V Q is equal to 6 minus 1.4, which is like 4.6 volt. Then you can say from the graph of Q for 4.6 volt, corresponding I is
0.45.
0.45 ampere shown. Right? Calculate the resistance R. देखो करंट इन R कितने हैं? 0.45 minus 0.4, 0.05 ampere. Voltage across R, that we already know. It is 1.4 volt. Then R is equal to VR by I. 1.4 divided by 0.05. It's like 140 upon 5. 28 ohm. That will become the resistance of this R. Calculate the total power dissipated in the circuit. In all the three together, right? Total power dissipated is, there is no free lunch, right? So total power dissipated is equal to power supplied by the battery. If you bought a car, then how much money was spent on the car? Well, that is same as the loss in the bank balance, right? So you can find the loss in bank balance. And how much is that power? He is asking what? Total power. The power is equal to power supplied by the battery. What is the formula for power supplied by the battery? It is EMF of the battery minus the current through the battery, right? And EMF of the battery is given to us. It is 6 volt. And the current through the battery is 0.545 ampere. So 6 volt into 0.45 ampere, which is like 6 5 are 30, 0 3, 27. So 2.7 watt.
Okay.
That is the total power dissipated, right? Total power dissipated. If you want, we can cross check. this should be equal to I square R x plus I square RY plus I square RZ, right? We can do
Yeah.
that, right? Yeah, but then or we can simply VI कर सकते हैं तीनों में, जो R सबका मालूम नहीं हमें, सिग्मा VI for XYZ. You will get the same answer. देखो
Oh.
X में कितना है, 4.6 वोल्ट है और 0.45 है, तो कितना हो जाएगा 4.6 इंटू 0.45. इसमें कितना हो जाएगा 0.4 इंटू 1.4, और इसमें कितना हो जाएगा 0.05 इंटू 1.4, 0.05 इंटू 1.4, तो 1.4 इंटू 0.45, तो 0.45 कॉमन ले लें तो कितना आ गया 4.6 प्लस 1.4, which is like 0.45 into 6, which is the same thing, right? Is equal to power supplied by battery, right? So this shows that there is no free lunch, right?
Hmm.
So you can do either way, but it is longer. It is better to do it from battery directly. It is just one step. Otherwise, you can add all these. Resistor P is removed. Suggest without any calculations the effect on this on the resistance of Q. Q में क्या असर पड़ेगा, अगर P को हटा देंगे तो overall this resistance will remove, right? So the alternate path will not be available, right? So whatever current is there, it has to go from here only, right? Hmm. What will happen? There is no current going here. So more current will try to go here. But more current means more voltage drop, right? So more voltage drop will be here and less voltage drop will be here. That means the current in the Q will reduce. That's how you have to argue, right? If you understand electricity, you can argue it like this. There is only one formula V is equal to IR, right? As we discussed.
Huh.
Hmm. And then some common source Kirchhoff's rules. Our total potential drop is 6 volt. That is supplied by battery. As R draws more drop, the potential drop across Q will fall. Consequently, current in Q and in the circuit and in the circuit will decrease. पैरेलल में जब रेजिस्टेंस को हम हटा देते हैं तो ओवरऑल रेजिस्टेंस बढ़ जाती है, और जब ओवरऑल रेजिस्टेंस बढ़ जाती है तो सर्किट में करंट कम हो जाता है। सो इफेक्ट क्या होगा? इफेक्ट ऑन क्यू, लेस पोटेंशियल ड्रॉप, लेस करंट, लेस पावर डिसिपेशन।
Okay.
Because power dissipation is the product of the above two. When both have decreased, the product will also decrease.
Hmm.
I think you'll have to stop.
Oh, okay.
Yeah, we have still some way to go.
Sir, can you send me the recording of this class?
Yeah, I'll send it.
Okay.
अभी तो बचे हैं कुछ पेज.
I think this is the last question. Yeah.
This is the last one.
Or no?
Okay, let's see. Identify with ticks in the table the forces that can act on electrons and the forces that act on the quarks. Electrons and quarks. Yeah, because on the quark there is strong nuclear force, right? And the electron there are like the beta radiation. They are only weak nuclear forces, right? Following data is available for atomic masses of the fusion reaction. So this hydrogen isotope 2H2 is combined with H3, deuterium and tritium, to give alpha particle and this thing. Very classic reaction, right? For the fusion.
Alpha decay.
Most of the energy is released here, right?
हाँ.
So that the energy release about 18 mega electron volt. ये तो कर लोगे आप?
This is
बताओ कितना
those.
होगा? डेल टाइम निकालो पहले. That will
Yeah.
be mass of the reactants minus mass of the product.
Yeah.
So how much is the mass of reactants? 2.0141 U
Plus
plus 3.0160 U minus 4.0026 U minus mass of the neutron in U. You know that? 1 point something zero.
Just checking. 1.008665 U.
1.008665 U, huh?
Yeah.
So you can find this.
Yeah. Sir, this is 0.0188.
0.0188. चारों
Yeah.
कर दिया आपने, right?
हाँ.
Then multiplied by 931.5 because 1
हाँ.
U is equal to 931.5 mega electron volt.
Yeah.
So how much are you getting?
17.512.
So that's what he's saying, right?
Yeah.
Which is nearly equal to 18 mega electron.
Yeah.
Estimate the specific energy of hydrogen by finding the energy produced when 0.4 kg of this H2 when they undergo fusion. What is that? Specific energy of hydrogen.
What does it mean by specific energy?
पता नहीं. Specific energy of hydrogen. Binding energy. Maybe it's talking about binding energy per nucleon. Per nucleon hydrogen is only one, right?
हाँ.
No, but it's just saying hydrogen. It's not saying hydrogen 1 or 2. By finding the energy produced. अच्छा, इसको बाद में देखेंगे, आगे देखते हैं, ठीक है.
ठीक है.
It is hoped that nuclear fusion can be used for commercial production of energy. Outline two difficulties of energy production by nuclear fusion. बताओ.
Very high temperature and high density are required,
हम्म.
which are hard to achieve on planet, on Earth.
Especially on a commercial scale. The experimental reactors. So far, the energy produced is less than the energy consumed.
Hmm.
But yeah, this is extra information. Basically, they want just these two difficulties.
Yeah.
One advantage of energy production by nuclear fission compared to nuclear fission. बताओ.
I mean, more energy is produced in fusion
Yeah,
reaction.
yeah, that's not that much of issue. But no long-term radiation problem, right?
Oh, okay.
There is no spent fuel which has to be buried inside the earth or something, right?
Hmm.
Because the fuel was just hydrogen and this thing, right?
Ah.
So they just disappear, right?
But sir, why is there more radiation in fission?
The fission, the waste, the daughter nuclei produced,
Oh yeah, it's like
they are radioactive, right?
right. Okay, okay.
So they will keep giving beta radiations because they have very high N by Z, right?
हाँ
So that means they want to balance their N by Z, which means they
हाँ
will try to convert neutrons into protons.
हाँ.
So that will neutrons into protons, that will give some beta minus, right?
Beta
So they
minus
give
radiation.
beta minus and gamma radiation for a very, very long time, hundreds of years, right?
Yeah, and they keep multiplying.
Yeah, and plus, जो उसमें ट्रांस न्यूक्लियर बड़े बन जाते हैं, दे विल अल्फा डेकी ऑल्सो, तीनों चलते रहते हैं. अल्फा बीटा गामा रेडिएशन दैट विल कीप कमिंग फॉर इयर्स एंड इयर्स, राइट.
Okay, okay, okay.
दिस प्रॉब्लम इज नॉट देयर.
हाँ.
नो डिफिकल्टी ऑफ disposal of spent fuel safely. These are the major attractions. Of
हाँ.
course, fusion, yeah, these are the major attractions. Yeah. See. Tritium is unstable and decays into isotope of helium by beta minus decay. Tritium decays into beta minus decay. तो क्या बन जाएगा? Beta minus means it will become proton will increase by 1, right? Helium 3, it will become helium 3. ठीक है? Plus electron it will give. And it will also give the antineutrino, right? When it gives electron. So I don't know whether it asked the reaction or not. I just wrote it right. State the nucleon number of helium isotope. That nucleon number. Yeah. So nucleon number is 3, right?
Yeah.
Because nucleon number does not change in beta decay, right? It
हाँ.
was 3, it will remain 3. 2 proton, 1 neutron.
Yeah.
ओरिजिनल में 1 प्रोटॉन और 2 न्यूट्रॉन था, बस इतना ही हुआ। इसमें टू
हाँ
प्रोटॉन है 1 न्यूट्रॉन, इसमें 1 प्रोटॉन था 2 न्यूट्रॉन थे।
हाँ
द फॉलोइंग डायग्राम इज एन इनकम्प्लीट फिनमैन डायग्राम डिस्क्राइबिंग द बीटा माइनस डिके
Sir,
ऑफ।
this isn't in our syllabus.
दिस इज नॉट इन द सिलेबस।
Yeah, because I don't remember learning this at all.
अच्छा, बीटा माइनस डिके हमने किया तो था शायद।
But the Feynman diagram.
या डोंट वरी अबाउट इट।
अच्छा।
इसमें बेसिकली ये बता रहा है क्या है, प्रोटॉन से प्रोटॉन थोड़ी बना है, न्यूट्रॉन से। ये हमने लिखा ना, जैसे इसमें बेसिकली क्या हो रहा है, न्यूट्रॉन प्रोटॉन में कन्वर्ट हो रहा है। तो न्यूट्रॉन यू आर गेटिंग प्रोटॉन प्लस बीटा माइनस प्लस इलेक्ट्रॉन
Plus
प्लस
anti-neutrino.
एंटी न्यूट्रॉन, बस इतना ही करने के लिए कह रहा है।
Oh, okay. Oh, cha, cha, cha. Okay.
राइट।
Yeah.
हम्म।
Okay.
आई थिंक वी आर डन, राइट?
Yeah.
ओके, ग्रेट, आई सेंड इट टू यू।
Okay.